Hello everyone, myself Dr. Harisankar Singh. In the previous video we have discussed about the Gauss law. Now in this video I am going to take some example and to understand the Gauss law. So the first example is calculate the flux through the base of cone of radius r as shown in the figure. Here the cone is given, the electric field line is passes through the base of cone and the surface area is directed towards the below of the surface, that is ds. So we have to calculate the electric flux passes through this closed surface of the base of the cone. So let us solve this question. So according to the Gauss law, we know that flux is equal to E S cos theta, where E is electric field and S is the surface area and theta is the angle between electric field and surface area. So let us understand what is E, what is S and what is theta. So from this figure we know that surface area through which the electric field line is passing, that is basically pi r square. If radius of this base is r, so we have the surface area as pi r square and theta is equal to 180 degree, because the direction of ds is downward whereas the electric field line direction is the upward. So angle between the surface area and electric field line is 180. So theta here 180 degree. Now we can put the value of S and theta, where E is the electric field line as given by E vector. So flux we can calculate from the formula after putting the value of S and theta. So we will get flux size equal to E in bracket pi r square, which is S, cos 180 degree, which is theta. Now we know the value of cos 180 degree, that is -1. So ultimately we get flux size equal to minus pi r square E. So this amount of electric flux passing through base of the cone, which having radius r. Now the second question is that a blue sphere A is contained within a red spherical shell V. There is a charge QA on the blue sphere and charge QB on the red spherical shell. So the question is that the electric field in the region between the spheres is completely independent of QB. That means in the region between A and B, the electric field in that region is completely independent of B. Is it true or false? So let us pause this videos here and try to think what will be this value. So ready? So what is your judge? True or false? If you are thinking it is true, then you are obviously correct. But if you are thinking it is false sentence, then you are wrong. So let us try here what will be this and how will be this. So the answer is it is absolutely true, because charge enclosed by only blue surface contribute electric field, not the red surface. And we already know that according to the Gauss law, electric flux we have calculated only for the enclosed charges. That means whatever charge is enclosed within that surface, we have to calculate the electric field. But in the region between A and B, there are no any electric field line that will depend on the charge QB, because out of the spherical shell B, we will have electric field due to the charge enclosed by B. But when we talk in between A and B, there is no any contribution of the QB which is located outer of the boundary. So I think you understand this, which is basically application of Gauss law. And the third question is that consider a topology given in the figure. A solid non-conducting sphere carries a total charge Q is equal to minus 3 millicoulomb. This is the non-conducting sphere and it carries charge. Q is equal to minus 3 millicoulomb and it is distributed evenly throughout. It is surrounded by an uncharged conducting spherical shell. These are the two cells which have the inner boundary and the outer boundary, which having two different surface charge density, that is rho S1 and rho S2. So the question is that what is the surface charge density rho S1 on the inner surface of the conducting cell? That means it should have negative value, it should have zero value, or it should have positive value. So what is your prediction? Just pause your video here and try to think and let me answer. If you are thinking it is negative, then it is wrong. If you are thinking it is zero, again it is wrong. If you are thinking it is positive, then you are correct. So let us see why it will be negative. Inside the conductor, we know that electric field will be zero because electric field is a conservative, so within the conductor electric field is zero, and we have studied also in the last videos. Now let us understand why rho s will be positive. So for the calculation of that, select a Gaussian surface inside the conductor. Here in this figure I have considered with the green circle. This is the Gaussian surface over which we want to calculate the total electric flux due to the charges enclosed by that Gaussian surface. And over this conducting spherical cells, we already know the electric field is zero. So the total charge enclosed must be zero because if electric field be there must be some enclosed charges will be there. And in the initially we know that minus 3 millicoulomb is enclosed, which is distributed over the non-conducting sphere. But when we enclose that surface with the Gaussian surface, then we have certain electric field lines there and again we will have electric flux. But the over conducting sphere, we know that electric field is zero. But question is that what amount of charge distribution over the inner shell of the spherical cell so that total electric field will be zero. So now with the green circle, what surface is enclosed now? This minus q and rho s1 is enclosed. So the question is that what is the value of rho s? And the value of rho s for the zero electric field, we know that it must be positive and its value will equal to positive of q. So that plus q and minus q will be cancelled to each other. So remaining no charge enclosed by the Gaussian surface. Thereafter we will have zero electric field. So that's why I am telling you the rho s1, that is the surface charge density over the inner spherical shell, will be positive. So obviously the rho s is greater than 0. This is the correct answer, that is option C. I hope you understand all this example, and in the upcoming videos we will discuss some more example to understand this. So stay tuned with me to understand about the electromagnetic field theory and enjoy your learning. Thank you for watching this video.